Corrosion is essentially the destructive attack of a material, usually a metal, by its environment, and it is something we must understand. The most straightforward type is called uniform or general corrosion, which affects the entire surface evenly. Its main peculiarity is that the metal loss is predictable, allowing engineers to easily calculate its lifespan. Next, we have pitting corrosion, which is often far more dangerous and less forgiving. This kind creates deep, isolated holes that can cause unexpected, catastrophic failure without much visible warning. Then there is crevice corrosion, a sneaky attack that happens in confined spaces, like under a washer or bolt head. It thrives there because the stagnant solution depletes oxygen, leading to an aggressive, localized attack. Galvanic corrosion occurs when two dissimilar metals are electrically connected in the same environment. Essentially, the less noble metal sacrifices itself to protect the more noble one, causing rapid deterioration there. Stress corrosion cracking combines mechanical stress with chemical attack to create fissures. The peculiar thing here is that the material fails below its normal yield strength due to this synergistic effect. Erosion corrosion is driven by the destructive power of moving fluids that carry abrasive particles. This movement constantly strips away the passive protective oxide layer, exposing fresh metal to attack. We also see intergranular corrosion, which attacks the metal's internal structure at the grain boundaries. Its peculiarity is that the component might look visually sound externally while having severely compromised strength. Selective leaching or dealloying is when one specific element is preferentially dissolved from an alloy mixture. The most common example is desensification, where zinc is selectively lost from brass, leaving behind a weak, porous copper structure. By recognizing these distinct mechanisms, engineers can select the right materials and apply the necessary protective measures to ensure longevity.